You guys may remember that recently I helped out my good friend Weasel2HTM with his driver's side power window, and it turned out that the power window motor has gone bad. And this is what the power window motor looks like from the 1991 Chevrolet S-10 that we worked on. And as you can see, it's basically just one integrated piece made from stamped steel, sandwiched together, and has these press fit fasteners on here to hold it together. And it's not really serviceable. It looks like the motor portion is right here. Here's the worm screw or worm shaft. Looks like there's one gear here and another gear here. So to allow for smaller size and lighter weight, looks like they may have gone to a reduction gear setup to further multiply the torque. I've never seen a power window motor quite like this before. If that date code is correct, looks like it might have been maybe a February 1990 part for the 91 model year. Typical power window motors look more like this. This is what I have as one of my spares for a car I no longer owned. This power window motor came from a 1987 Chrysler Fifth Avenue or Dodge Diplomat or Plymouth Grand Fury, that basic body style where you clearly have a traditional motor with the end caps held on with these through bolts, your worm shaft coming out of here, and then there's usually a plastic gear inside of here that turns this metal gear. And it's quite serviceable. You can take off the end cap here, get to the commutator and clean the commutator, maybe replace the brushes, lubricate the bushings in the front and back. And you can also pop off this plate here and repack the grease inside. And I've always been a very curious person, and this power window motor failed in a very unusual way that caused both Weasel and I to really dig in and put our investigative caps on to see what was going on. We started out with the basics, checking out the power window switch, because 9 times out of 10 a lot of power window failures end up being just dirty contacts in the switch, and you can kind of agitate that switch back and forth to get the window to come back up. And he actually was able to get the window to come back up, but it took a very long time. But what would happen is that the motor would run for a short period of time and stop, and then it wouldn't run at all for several minutes, and then you can hit the switch again, it would run for just a split second, and then stop, and you wouldn't be able to run it again for a few more minutes. And I've never experienced that failure mode in a power window motor. Typically, not all the time, but typically these power window motors have built into them a thermal circuit breaker. It's basically just a bimetallic strip in there with 2 silver contacts. And they have to have some period of time to get hot to cause that bimetallic contact to open up and break the circuit. And what ends up happening is that once it opens up and breaks the circuit, the bimetallic strip cools down and it closes again. And it does this over and over again, and it basically causes the motor to slow down. And part of the reason they use that is for safety. If your car is wrecked and underwater, or if you have a circuit problem and you really need to get out of the car and the door is jammed or something, they want the motor to run at least at a minimal speed. That's basically the last ditch effort versus having a fuse which blows, and once the fuse blows there's just no hope of getting the motor to work at all. You can find these circuit breakers also in the windshield wiper motors of most cars, where if you have a overload condition with the motor, such as your wipers are stuck to the windshield due to ice and snow or some kind of debris, the wipers might work slowly, or they might not work at all until the debris is cleared, but once the debris is cleared the motor will resume working, and that way the owner doesn't have to do anything to get it to work other than clear the obstruction, and the motor starts working again. That's much better than a fuse, and actually much safer. And at least in the American cars, the headlights are the same way. If you might have seen some of the older American cars going down the road with 1 or 2 dim headlights, That's usually the circuit breaker inside of the switch opening and closing, creating a duty cycle and effectively dropping that voltage down to safe limits so you don't overheat the wiring. I don't know much about this motor, and I've always been a very curious person, and what I wanted to do was show you guys exactly what this motor is doing, and also to see if I can get this thing apart and see what might cause this particular failure. I've also got this other motor here which is working, hooked up through a very large capacitor, and I've got a automotive emergency assist battery here as my power source. I've got a amp meter turned on over here, and if my contacts are still hanging on there by a thread, what you should hear is the motor turning just for a split second and the current spiking up. I'm not sure what the value was when I was working on it with Weasel. It might have been 2 or 3 amps, and then it drops back down to a very minimal value and the motor won't run anymore. I was a little bit concerned because we were holding the switch down, and usually when you hold the switch down, if the motor's locked, you'll heat the wiring up pretty quickly. A locked armature can really draw a lot of current, especially with series wound DC motors. The more loads you put on them, the more current they'll draw, and they'll basically destroy themselves. So I'm going to go ahead and hook this meter up to the positive post of the battery, and hopefully you guys are going to see and hear what we've been dealing with. Okay, hopefully you heard and saw the motor turning. The current is falling off fairly rapidly. I think I might have went to 1.4 volts or something like that. I'll remove the power. Now we have 0 amps. That's basically the same thing as releasing the power window switch. And wiring hasn't gotten hot. There wasn't really enough current for a sufficient period of time to generate any heat to cause the circuit breaker to open that quickly. I'll go ahead and try to apply power again and see if I can get the motor to run. And it might have spiked up to 1.6 amps. Now it's down to minimal 0.2, 0.3 amps. You might have heard the motor click. That clicking sounds like the motor might be locked, but it really isn't because it was just turning a few seconds ago. I'll try it again. And now it won't even go to an amp. So that's an extremely unusual failure. Most of the time when these power window motors fail, it's usually mechanical. You might have a gear problem inside of here where, at least on a Ford, plastic gear plugs rot away and the motor just sits here and freewheels but doesn't turn this gear at all. And if the car is really old, the brushes inside will wear down to the point where you just basically have the springs rubbing against the commutator, and you'll either have a fully open circuit or extremely high resistance in here, which would not allow the motor to turn. And just for the reason I have the capacitor here is to kind of simulate what's going on here. There's nothing wrong with this motor. This motor works perfectly fine. I'll take one of the leads off the capacitor and we'll demonstrate. Runs perfectly. And we'll go ahead and put it back. And if you guys, as a side note, if you guys are doing any troubleshooting for your wiring in your car, most of these power window motors get the positive and negative on these 2 leads, and the switch just reverses the connection there. It doesn't get power from one lead and ground, contrary to common sense actually, because in most systems in cars, the body of the car acts as the ground, but in this particular case, the way these motors are usually set up, all the power is provided with these 2 wires here. Now you saw how the motor ran and everything. The reason I have a capacitor here is to simulate the failure mode with this motor, and what I'm going to do is essentially charge up this capacitor through the resistance of the motor. And this is a very large capacitor. It's 320,000 microfarads at 10 volts. This came out of a high current linear power supply. It's a computer grade hermetically sealed capacitor. It looks very much like the super caps you would find in high-end audio equipment. And what's going to happen is as that capacitor initially starts to charge, it's going to draw a lot of current through that motor and cause the motor to run. And as it charges up, that current's going to fall off. So now what we'll do is we'll go ahead and set up for that. And I'll show you guys what I mean. We'll keep the same amp meter. Just want to move it to the other circuit. And now we'll try to run this motor through the capacitor. And you'll hear it'll have the same kind of failure condition as the original motor from the 91 S-10. Now the capacitor is fully charged and current's falling off rapidly. I'll remove it from the circuit. Now we got 0 amps. And now I'll try to reconnect it. And I've got nothing. You can sort of hear the motor click, but since the capacitor is fully charged, it's not going to take any more current. And now what I'll do is I'll discharge the capacitor and see how long I can run that motor just for entertainment. It's pretty impressive for a capacitor to run such an inductive load like that for that length of time. But I always like kind of playing around with stuff and seeing what's going on. Obviously, this power window motor could not have a capacitor of this capacity inside of there. It would be nice to think to yourself, maybe there's some component in here, some active component in here that might have failed, allowing a filter capacitor for noise, radio suppression capacitor essentially, to become in line with the circuit and cause that kind of failure. And there might indeed be a radio suppression capacitor in there, I don't know yet. But radio suppression capacitors are usually much smaller because they're filtering out higher frequency noises. This is made to filter 60 Hz or 120 Hz depending upon what kind of regulator, or what kind of rectifier you have. So I'm going to go ahead and tear all this stuff down, and I'm going to take a drill and drill out these fasteners here. It looks like it's just bent over. I'm going to go ahead and take this thing apart and see what's going on. My hunch is that it's going to be a brush wear of some kind, and as the motor starts to draw current and run, it just arcs excessively because there's no brush material left. You're just running on the springs or running on the flexible copper wire that's in there that provides current for the brushes and doesn't have enough current to run anymore. So let me get this motor outside, drill out those fasteners, and see what's going on in there. Okay, I've got the motor apart finally. That was actually quite a bit of work. It became very clear that General Motors, or Delco in particular, did not want this assembly taken apart. It's basically a disposable unit, unfortunately, unlike these motors that can be rebuilt. If you look at the parts catalog, for example at O'Reilly's or AutoZone or Advance, they do sell remanufactured or reconditioned or rebuilt motors. I'm not sure exactly how you would do that unless you're basically just making use of the same gears and maybe the armature and coming up with your own brand new stamped steel casing and putting it back together again. But anyway, here's what's going on inside. You've got the armature here and 2 permanent magnets, and here's your worm gear. That's going to one reduction gear here. Then this gear, this is the much larger gear, and this larger gear turns this smaller one, and the smaller one actually connects to a sector gear, kind of like a pie-shaped sort of gear that actually moves the regulator arm. So this motor is actually quite teeny. I mean, it's not even as large as a windshield wiper motor. But because of the extensive gear reduction taking place here, it's actually capable of putting out quite a bit of torque and can really do some damage to your fingers if you get your finger pinched between the window and the U-channel when you're trying to roll it up. I'm not sure what kind of safety GM built into here. Ford uses plastic gear plugs that destroy themselves if too much torque is required to get the window up. GM may have done something similar. I just haven't gotten the mechanism far enough apart yet to find out. And of course there's no large capacitor or any capacitor in here at all. But I think what the problem is typical brush wear. You can see that commutator back there is extremely dirty. Basically, for those of you that don't know, what's basically going on here is you've got a positive and negative here, or a positive and negative there, depending upon the rotation, and you're just passing current through these wires to oppose the magnetic field from the permanent magnets. And the purpose of the commutator is to constantly reverse that as the motor turns, and that way you're always guaranteed to have a north pole and south pole here, or actually north and south to repel each other to keep the motor turning. And that's how this winding is laid out. But anyway, you can see just how dirty that commutator is. I don't see any clearance between the brush holder and the commutator. It looks like the commutator is riding directly on these two brass brush holders. And you've got this Weasel and I both noticed this ooey gooey sticky mess all over the back of the connector when we took it out of the vehicle, and the seal is basically deteriorating. You can see it just doesn't return back, and it just leaves a tarry mess. And that goop has gotten all wound up inside that commutator there between the brushes and everything. It's just all nasty and black. Let me see if I can work this thing out of here and get a closer look at the commutator and brush assembly and see if I can tell exactly how worn down they are. Those magnets are very strong. That might make for an interesting thing to keep, actually, just to play around with. I'm going to go ahead and separate these just to avoid finger pinching accidents, like what's just almost happened there. The magnets are attracting everything. I'm going to go ahead and pull the brush assembly apart, and they're probably going to come flying out at me. Of course, this thing rotates freely. It's not bound up or anything. And there's one of your brushes. Really good quality brush. Got a lot of copper in it versus graphite or lead or something like that. Actually, doesn't appear to be as worn down as I thought. But if you look here, you can hardly see any copper on that commutator. In fact, it's so covered in that gooey substance that used to be a seal at one point, you can't even make out the individual distinct halves of the commutator at all. And here's the brush assembly. It's just as nasty inside. And if we, here's some of this black tarry stuff. If we clean this commutator, you can get a better idea of what it should look like, but it's actually quite hard to clean because of that gooey stuff. This towel just ends up spreading it around. What I really should be doing is getting some brake cleaner to act as a solvent. That's somewhat what it's supposed to look like, bright and shiny, and you can see the different halves. So I wouldn't be surprised at all to find out that the root cause of this particular failure was a bad end seal, a deteriorating end seal, where the electrical connections are made. As you can see, they are just deteriorating over time, which contaminated the commutator and caused a high internal resistance and stopped the motor from working. Why it would start and then stop, and you have to wait for a while before you can start it up again, it's not very clear to me. It's definitely not a heat-related issue. Nothing was getting hot. It may be that as this thing started to rotate, it smeared some more of that gooey stuff around and stopped it from rotating, and then after a period of time, maybe the gooey stuff sort of fell back down due to gravity and made slightly better contact with the brushes, and the motor would turn again and then spread it around again and then stop. That would be one theory. That looks just like normal deterioration. It's kind of similar to what you guys would see on these Ford airbags. I've got the airbag from the wrecked Crown Victoria. And if you guys own Fords, you know exactly what I'm talking about. Over a period of time, of course I got it upside down, over a period of time, the interior just gets sticky. As you can see, it's collecting dust and all that kind of stuff, just all kinds of debris. It's just very, very sticky. What this is actually a paint, an interior paint sprayed on here. That's the airbag is actually black, but you can see the material starting to decay just over time. This was never exposed to the sun. This is the part that's behind the steering wheel, and you can scratch it off, and it's extremely you can hear it, extremely gooey. So that's kind of consistent with what we have over here with this material, just very, very gooey and just deteriorated over time and got ruined, worked its way down in between the brushes and the commutator and caused a failure. Motor, this is not really much to look at. It's got some pretty beefy windings in here, which are kind of neat. But anyway, just kind of wanted to share that with you guys, a little bit of a in-depth look on why this motor failed. I'm not really too surprised how it failed. Basically just worn brushes, or in this case a dirty commutator. These things are actually pretty simple once you get them apart. This design is not really much different than that design, except this is not a reduction motor. This is quite a bit heavier than this assembly right here, and with the government's ever-increasing demand for the CAFE standards and better gas mileage, manufacturers looking for anything they can do to save weight, and that's probably why they ended up with this particular design here with all this reduction going on, is just to allow for smaller magnets and things like that. Motors are actually have a lot of material in them, a lot of copper and a lot of ferrous material to act as the magnets, and they get pretty heavy, so the smaller you can make the motor itself, the more weight you're going to save. Everything else is just gears and the housing. So I just couldn't resist. I had to get this thing apart and see why it failed like it did. Usually most of the motors that I see, once they fail, or once the brushes wear out, they're just worn out. They never work again, and the motor just never works, and you can't get the window up. This was a bit of a unique failure, because it looks like we caught this failure just in the nick of time, because Weasel was just able to get the window up before it rained recently. And I mentioned Weasel2HGM before at the beginning of the video, and he's also a fellow YouTube user. And you guys might want to check out his channel. He's got a lot of interesting videos on there. Anything from car repair to electronics repair to just general interest kind of stuff. So hope you guys check it out, and I think you'll like what you see.